This is the introduction to section 6.1, part 1. And in section 6.1, we're going to talk about the polygon angle sum theorems. Okay, polygon angle sum theorems. First thing we're going to look at is our objectives here. We're going to find the measures, find the sum of the measures of the interior angles of a polygon. And that's what we're going to talk about here in part 1. And in part 2, we're going to talk about the sum of the measures of the exterior angles of a polygon. So the exterior ones are going to be in part 2. Interior ones are going to be here in part 1. Now, first, before we get started, let's discuss here what is a polygon. Well, a polygon is a closed figure formed by 3 or more segments. Okay. Now, if you look at this shape right here that we have a rectangle here. This is a polygon. We have 4 sides in the figure, and they're all closed. And what it means by closed is that all of the end points of the sides intersect. A not closed figure might look like this. That's a not closed figure. Not all the segments intersect with each other or meet. Okay? So a polygon is a closed figure formed by 3 or more segments. All right, so it says the sum of the interior angles of... Okay, now we have names for polygons, and in your notes you'll notice you have a sheet. I'm not going to spend much time on this because this is something that you're going to need to know, you're going to need to memorize. This is the number of sides, and this is the name for each one of these figures. Now, we do not have a name for an 11-side figure, but once we get past 12, or essentially 11 and 12, once you get to 13, 14, and so forth and so on, we call it a 17gon. So, for example, a figure with 7 sides is a heptagon. A figure with 8 sides is an octagon, so forth and so on. Okay, so we have specific ways to name different polygons. Now, what we're going to look at now is figuring out the sum of the interior angle measures of a polygon depends on the number of sides the polygon has. Now, let's talk about what these means. The interior angle measures, that's the inside angle measures. Okay. Now, if you go over here, this is something you're going to have to put in on your notes because we don't have this in here. So, draw yourself a rectangle and a pentagon in this case. And what I'm going to do is I'm going to show you how we come about finding the sum of the interior angles. Now, we've talked about triangles in the past, and you'll notice that if I draw a line from one vertex to another here, and I make that my diagonal, that creates 2 triangles. Now, how many degrees do we have in a triangle? Well, we know there's 180 degrees in a triangle. And there's 180 degrees in this triangle. Okay, so what we can now say, in this case, a 4-sided figure, what is the sum of the interior angle measures? Well, if I take 180 and add 180, I end up with 360. Okay, now, you'll notice a rectangle has 4 sides. Okay, 4 sides. And you'll notice that triangle has 3. Now, if I look at the pentagon, and I do the same thing with the pentagon, I want to create as many triangles as I can with the pentagon using one vertex. So in this pentagon, how many triangles do you see? In this case, you see 3 triangles. So I know this is 180, and this is 180, and this is 180. Well, if I add 180 3 times, I end up with a number of 540. Now, pentagon has 5 sides. Okay? Pentagon has 5 sides. And if you look, a triangle has 3. A triangle, in this case, has 3. Now, as you're looking at this, what you want to figure out, how many triangles do you have in the picture? Well, in the top case, we have 2 triangles. The bottom case, we have 3 triangles. And you'll notice no matter how many triangles you make, it'll always be 2 less triangles than the number of sides you have. So the reason I went through that is to get you to understand where we're coming up with the formula for it. So it says here, the sum of the measures of the interior angles of an n-gon, n stands for the number of sides, which is what I have here, is take the number of sides, subtract 2, and take that times 180. The number of sides minus 2, take that times 180. So all you're going to do now is substitute into that formula the number of sides. For example, what's the sum of the interior angle measures of a heptagon? So a heptagon, how many sides is a heptagon? That's going to be important for you to know. That's 7. So I take this formula, n minus 2 times 180. And the reason I have n minus 2 is because there's always 2 less triangles in a shape. So now this is 7 minus 2 times 180, which is 5 times 180. So the sum of the interior angles of a heptagon is 900 degrees. Okay. So, second example. Hit pause. See if you can come up with an answer for the second example. Okay, now that you've hit pause on the second example, let's take a look at it here. Again, n minus 2 times 180. My number of sides is 17 times 180, which ends up being 15 times 180, which tells me that there are 2,700 degrees in a 17-sided shape on the inside. Okay. Now let's take a look at the next example. It says the sum of the interior angle measures of a polygon now is 1,980. Now I'm giving you the total number of degrees and I want you to find the number of sides. So again, n minus 2 times 180. And in this case, I know that my total number of degrees is 1980. Now you have to solve the equation. So I'm going to divide by 180. And n minus 2 now, these guys cancel out, is going to equal 11. So if I add 2, n equals 13, which tells me that this is a 13-sided figure. Okay? Okay, now, the last part here of section 6.1, part 1, talks about, we're going to talk about certain types of polygons, and they've got 3 here. You got equilateral polygon, equiangular polygon, and a regular polygon. An equilateral polygon is a polygon with all sides congruent. An equiangular is a polygon with all angles congruent. And a regular polygon is with both. All the angles and all the sides are congruent. So a regular polygon. Now, using regular polygons, we're going to be able to find the measure of each interior angle of any regular-sided figure we want. Okay? And the formula for that is n minus 2 times 180, and then we're going to divide that by the number of sides. So essentially, we're going to do the same thing we just did, but now to figure out how many is in each angle, I'm going to divide it by the number of sides. Okay, so now let's go through a couple of examples here. All right. So as I look at these examples, what's the measure of each interior angle of a regular nonagon? Nonagon is 9 sides. So I'm going to use the formula n minus 2 times 180, and we're going to divide that by the number of sides. So we take 9 minus 2 times 180 divided by 9. 9 minus 2 is 7 times 180 divided by 9. In this case, when I multiply 7 times 180 and I divide it by 9, you get 140. That means that each angle in this case is 140 degrees on a regular 9-sided figure. Okay? Okay, so let's take a look here at these last 2 examples. The second example here. What is the measure of angle Y in pentagon TODAY? Well, we don't know what that is. We're going to make that X. The first thing I need to do is figure out what the sum of the interior angles is. So I've got a 5-sided figure, subtract it by 2, times it by 180. So in this case, I've got 3 times 180, which is 540 degrees total. So all of these 5 angles have to add up to 540 degrees. So I'm going to take the X plus 150 plus 120 plus the 90 plus the 110, and that's going to equal 540. Combine my like terms, and I get 470 when I add all 4 of those numbers. Subtract 470, and I end up with the X value of 70 degrees for that angle. Okay, here's what I want you to do. I want you to have this problem right here completed by the time you come to class tomorrow. Okay, what is the measure of angle G? And then also don't forget to complete your WSQ with section 6.1 part 1.